Okay. Hello, everybody. Fuck LLMs. Sure. And LLVM and CMake. Fuck CMake. I don't know about LLVM, but I'm gonna go with, yeah, sure, what the hell. I don't know about, hold on. Okay. That is a weird way of, phrasing an advertisement, their stream elements. Sorry, it's not an advertisement. It is they sent a sponsorship opportunity, which makes it sound like I'm just running a sponsorship without my knowledge. So, good wording on that one. Good, incredible wording on that one. I do remember you. Hi. I'm not feeling amazing today. I have some major sinus. Well, major. They're a lot better now. They used to be major. Sinus issues, and the pressure I am feeling on my face at this very second is annoying. So, hoping to get through the stream. But I think my voice is also gonna sound like extra nasal. I guess that's gonna be a thing. Okay, today we are, sorry to say, not doing Le Triangle. I forgot to update the title of the stream. And the thing is that I would lose all day on this. So, and also, I don't know, it wouldn't have made me better. It's not like I can sleep it off. It just kinda happens. Really, the only long-term solution is surgery. Anyway, I don't know, maybe it'll be a short stream if I really can't bear it. I guess we'll see. I look incredibly blue today. It's the camera being weird. When I... Is it just like when I get closer it gets... It's just the camera being weird. Alright, wake up, buddy. I need you. Um, blue and pink. A little bit of both. No, I'm pink. Anyway, yeah, we're not doing Le Triangle now blue again. Blue pink in your area. I am not doing Le Triangle today. I am doing Le Système Opératif. Surely that's how you say it. Yeah, alright. I'm doing French lessons, and then we're moving on to C. That may be great if we have time. We'll see. Operating system in français. Système opérateur. Not operatif, opérateur. I've already made this mistake in English, now I'm making it in French. Amazing. Trying to get all the languages, you know how it is. Okay, today we are doing le système opérateur. I'm very slowly, very progressively turning these into French streams, by the way. Despite me not speaking French and having a slight disdain for the language. Okay. Now, I'm working on the operating system a little bit, though I'm not expecting it to take a whole lot of time. Fuck that guy, sure. Okay. Actually. Yeah, fuck Jeff. Okay, my system has a lot of modules that specifically just expose different parts of the system to the file system, essentially. They mount themselves to slash something, and they usually provide some functions to read and write files within them, and then you can communicate with them through files, because the modules themselves handle the writing and reading, so yeah. Right, TTS. Okay, let me take a second to do that. I have a reminder on my phone that I've just been ignoring since 10 a.m. God, what's the name of the website though? It's not Stream Elements. It's Sound Alerts. All right, we're gonna log in. We need to authorize it apparently, even though it's supposed to be already authorized. I'm gonna fix the camera. How do I covered my face and it kind of like changed the color, so that's interesting. See? What the hell? Then go to setup. I just gotta copy this. And got a browser in. Why would you make it visible by default? Jesus Christ. Alright, should be good. Yeah.
Remember that last December when he was not a member of the channel battle in Seattle lol folding all balls all mole for 4 hours.
I hope you heard that now. Wait, you get your channel points refunded. Let me do that. Wait, did you not hear that? Alright, it says an error occurred when trying to refund. Alright, you heard that? Great. Wonderful. Okay. Back to what I was saying. Yeah, most of my drivers, most of my modules of my system are exposed through this very simple interface to the file system, so you can read and write to them. And that is useful for communicating with certain modules of the system without there needing to be an explicit API for that. For example, there's no audio API, but you can communicate through the file system. That's not the more efficient way of doing it, obviously, but I haven't bothered with one. I haven't needed audio, so if you want audio, this is how you do it for now. Once I actually get to, you know, a proper API for sound, you can use that one, and it'll be a little bit faster. With that being said, this system module thing only exists within things like drivers and a few other things, like the boot partition is also exposed through this very system. That's literally the one that's here. And also the shared partition, which is a 9p file system driver, which allows you to communicate between your host computer and guest operating system. Both of those are also exposed like this, but ideally you would be able to expand this system so that userland applications can communicate with each other through the file system. So they should be able to, well, just applications in general, just not necessarily userland, but like processes in general. The thing is, processes that are in the kernel have access to all the kernel functions. So if they wanted to set up a module, they could. Userland applications have no such privileges, so we're gonna let them do that. And also, normal processes from the kernel should also be able to do it through this same way without needing to do it directly. I technically did already do file system. What do you even call them? Process file system? I don't know. A while ago for my windowing system, but then it ended up not being the best way of doing things because obviously when you do things this way, you have a process that talks to the file system and then another one that responds, but you have to wait for them to be both scheduled, so it takes a while, and that would make Windows quite laggy. And I found a better way to do it anyway, so I didn't need to do any of that. But another issue that there is I can create a process, and that process can mount itself to /shared, but when that process exits, /shared should no longer be valid. And sure, I can leave it up to the process to clean that up, but that probably isn't the right way to do it. Most likely, you want the process to be able to, not the process to be able to clean it up, the kernel to be able to clean it up. When a process exits, or when it crashes, for example, then you get rid of that system module. That's the way that it should work. What did I just do? Did I create that? I don't know. I don't know what I did. But I was moving the mouse and I accidentally bumped into my microphone stand and I clicked the button and it, I think, dragged something into that, but I don't know what that was. Anyway. Alright, so I want processes to be able to attach themselves to the file system. I'm thinking, should I limit it? Yeah, I should. I'm going to limit them to one module per system. Unless I need more. More than that. But I think one should be fine. Right, and essentially this is all my process information, which honestly could use a little bit of a cleanup. Like, I think this is no longer needed, pretty sure. But yeah, could use a little bit of a cleanup. Either way, we're going to add a system module exposed file system. So when I reset a process, which happens here, I'm gonna do the cleanup first and then the actual setup. When I kill a process, I should check if it has one of these file system modules. And what is your damn problem? Right. How do I know for sure that you have a valid module? Let's say that I expect an init function. If you don't have one, then I cannot initialize your module. So it never got loaded. Right? If we load it, if you have a module, then you probably have a dinit function. What is it called? fini function, which we are going to call to let you clean up your resources if you have any. And then we currently don't have a way to remove modules. Most of these fni functions are not even implemented, so that's fun. But, oh, we do have an unload module. All right, so we just call that unload module, passing in the proc exposed fs. That's it. And for that matter, I actually will not even do the cleanup here. I'll do it in the expose function. I think that makes more sense. That way, if there's anywhere else that I need to unload modules, it's all happening in the same place. All right, we're going to want to include, I believe, driver bait. No, module loader, which should automatically clean up the processes module. Now, unload module does nothing. Cool. But the same logic that I wrote before, if no module in it, then return false. Because how did you manage to get a module that loaded? That's another thing. If the module doesn't have an init function, then we return false when loading and when unloading. Then if the module does have, we're rewriting this part, a fini function, then we're just going to call that. And then remove. Okay, we need to call this function on the modules. Oh, that's another thing. If modules doesn't exist, then the module never got loaded. I guess that makes sense. All right. We can actually search for the module that we're removing with this same fs function. So we just get the node like this, but the path is module mount. And then we pass this node to be removed from the list. Since it's a linked list, which it shouldn't be, but right now it's a linked list, then it should just update the pointers. Okay. That should be the logic for module unloading, but how can we know? First off, we're going to put some prints. One for loading and one for unloading. Right. And then before we get into the syscall part of this, we're just going to test it on one of the kernel processes, like the Windows DOS process. So I started here. And we're going to need to include the function to do that from dev module loader. And probably shouldn't have called this path dev. It made sense back then, but now it kind of doesn't anymore. Okay. The name of our module is going to be test. The mount point of our module is going to be /test. The version number is going to be 1. There's a version number formatter, but we can't be bothered with that. The init function is going to be, we're just going to create a bool init. Yeah, init like that is not going to work. And I'll do the same for this one. This is going to be init test. And this one is going to be this. And I'm not going to fill in any of the other information, which is like the actual behavior of the module, because I don't expect it to have any behavior. Okay, so you load a module. And then, yeah, this process kind of never quits. Does it? Never consider that. I put it in the windowing system, and the windowing system never quits. Not that any of them do. Of the kernel modules right now. Not that it matters because it didn't compile. What is your problem? No, what is your problem actually? Cannot open linker file. I am in Spain, not Italy. Cannot open linker file, linker script file. Oh, no such file or directory. What happened? What are we complaining about here? Who is complaining about this? Home bin clanked. Oh fuck. It's that folder I created by accident. Now, why isn't it going away? Okay. Well, that's cute. So nothing is working. Although, yeah, this loaded module is used to load the logging module. So how are you logging without a logging module? Yeah, that was the problem. Okay. We won't need that necessarily, but init done, okay. Again, I put this in a process that never quits. So how can we know that it actually deinitialized? Well, I guess we'll know once we load a proper userland process, but in the meantime, I'm going to just unload module, test mod. If not, I could put it in like one of the terminal kernel level processes like ping or traceroute or shutdown. Although shutdown doesn't really make a lot of sense, but whatever. Oh? Why did it crash? Hello? Oh, okay, because I load and unload the module, and that goes to module loader 20. I thought it was an unrelated bug, but no. It's related to this. Uh-huh. Which you're complaining about me passing... okay. Yeah. That's the issue, essentially. Although maybe that's not an amazing idea, what I just did. but it does work. It did load it and unload it. It's not a great idea. That's probably better. Okay, it does load them and unload them, but we don't really know what that means. Okay, I can set up a simple read which is just a function that returns a size hey Samarth. It's hard to read people's YouTube names since they now show usernames instead of names. It's so dumb. YouTube making the platform worse. Okay, if I'm not mistaken, to read, yeah, I need to pass a const char for the path, and I need to tell it where to read into, which is a void buffer, actually, not a char buffer. And then I need to tell it how much to read. And I need to tell it the cursor, so where to read from. Thing about that is I'm just going to return a 0, and I'm just going to print read done. Alright, so we're going to try to access, I did that wrong. Const char void star. Oh. Wait. The simple read doesn't use a cursor? Okay. I guess it always reads from the beginning. Anyway. We're going to read a certain amount into a buffer from this path. Except we're not going to do any of that, we're just going to print. But the point is, we can now call simple read on /test /hey. Again, buffer does not matter. Size, maybe they do matter because there might be some checks in the file system. So I'm just gonna put some random values in there. And the name of the function is, it's probably that one that I used. It's just not included. I mean, full name as in, you know, something that I can read easily, not just auto-generated usernames. I forgot to write the second part of the test. But yeah, it did work the first time. After I unload the module, I expect it to not work again. So I expect to see init, read, f-init, and then I don't expect to see another read after the unload module, which I forgot to read out. Okay, yeah, that looks good. Let's make this return a 10, and then tell me how much you read. Okay, the first time it reads 10, the second time it cannot reach the module anymore, so it reads 0. Perfect. Okay, so it is working. The part that we haven't been able to test properly is it unloading the module when you unload it from the system. But I guess that makes sense. I'm thinking, however, about virtual memory. Because that's such a great invention. I love that we have virtual memory, such a useful thing. I pretty much only have it because like ELF files don't work very well without it. All right, so in order to have a userland process have a system module, I can give them I have to expose the definition of it, which I'm going to do through a file called system module.h here in the shared library where they're all going to be able to pick that up. Include types and include fs.h. That should resolve everything. We're good. All right. So I am able to create, much like I did before, actually exactly like I did before. So real quick, just go to kernel processes, Windows, and just bring all that back. I should be able to move my module to exist within userland without these includes anymore. And now with the files system module include, everything looks good. I need to create a syscall for this. I don't want to call it a system module. Oh yeah. Add a mount point maybe is a clearer way. FS module. I'm going to call it an FS module. Okay, so I'm going to create a new syscall for this. I'm going to call it load FS module. And of course also the onload FS module. You're going to have to pass in a system module pointer in both cases. Then I'm going to create a new syscall code for these two. Oh no. Oh no. The name is going to be the number of the syscall is going to be an interesting one. What is it? Yeah. Uppercase. 66. And one more after that. We're then going to define them here, which for some reason doesn't have syntax highlighting. And that's all I need to do on the userland side. Wait, hold on. Might as well just finish. Load fs module as the test mod that you created. Cool. Then on the syscall side, on the kernel side, I mean, we're going to missing dog alarm. Oh. Damn it. I messed up my whole screen. He's there, he's there. What does this return? Returns a boolean, right? Although it should return a uint64 because that's kind of how I set up these things. Syscall load fs mod takes a process context and a similar function for onload fs module takes a process context. We are then going to access the system module pointer by casting the system module pointer from the context proc x0. Why are you not auto-completing? And then we're going to call load module with mod. Here we're going to replace it with onload module. Up here we have a million imports. Well, what's one more? The module loader, and then load module. What happened there exactly? Okay, and you're going to return this as a value. We're then going to, for both of them, set up the load fs module code as syscall fs load fs mod without any arguments because it's a function pointer. And this one is going to become onload. Cool. Is there anything missing? No. The thing that I was mentioning before, however, is virtual memory. These here are function pointers, and the process exists at 1000 hexadecimal, which means that these exist at, you know, this address. We don't know exactly where, but somewhere in that range of address. That's not where they really are in the kernel, and that's not how the kernel is going to be able to access them. So we're going to need to translate the kernel these function pointers to the correct function pointer. So I'm pretty sure so long as this module talks to itself, it will work. But when you unload, it will crash, most likely. If it even works at all, which I'm not sure. Okay, I moved the file, so everything needs to be recompiled. It loads, and surprisingly, doesn't crash when unloading. But where's my logs? Oh, well, it doesn't unload it at all, because I did forget one part. When you do the syscall, you gotta attach the exposed file system to the process. Hey lol yet. And then we're gonna do the translation there. We're not gonna translate the own modules, so we're not gonna modify their data. We're just gonna use ours. And for that matter, the syscall might not even need this at all. So we'll ignore that. And what we will unload is the contexts exposed fs. No, wait, hold on. Pointer. And then we're going to modify the syscall itself to actually like not have any arguments because it no longer has arguments. It's kind of just wasted. It's just a function signature. Internally, it's just assembly, so that's all it takes. Okay. Pretty sure now it is gonna crash when it closes, and we'll have to do that translation. And honestly, it's just a little bit of math, but I didn't mention how my whole face hurts, right? So. What do you mean you didn't crash? What do you mean? Nah. Urgh. God damn it. You should have crashed. I'm angry that it doesn't crash. That's the level that we're at right now. I'm angry it doesn't crash. Cool. Do I still have the unloaded module? Here it is. And the loaded module is not a very helpful thing. So can I just take that log and stick it in here? Is there by any chance a while loop or something like that? Yeah, there probably is, because it's displaying an image. There we go. Now we're talking. Now we're talking. Yes, you crash. Very good. It crashed when loading, not when unloading. God, that wasn't supposed to happen either. Okay, and it doesn't even tell me where it crashed. Okay, yeah. 13D4. Where the crash is somehow didn't get translated. But the crash is permission fault. Okay. I'm surprised to see it, to be honest, because we're still within the process, but okay. Alright. We'll need to do the function translation. I'm happy that it crashed because I expected it to crash, and it wasn't crashing before, which means that something was already wrong. It crashes. I expected it to crash because I haven't finished doing everything I needed to do. That makes sense. I'm not done. It wasn't crashing before, which means the part that I did do wasn't working. Now it is because it's crashing. Although again, it's crashing earlier than I expected, but it still makes sense. My assumptions are still right. Okay. If I'm not mistaken, does VA contain the value that I expect to read? I believe it does. No. Oh, wait, what do you mean no? That's not right. Hold on. Okay. When I load a process, I use virtual addressing. By the way, I have a little like disassembler here that's doing nothing. It's just sitting there. Okay. This min address should be okay. Min address VA. Why is it 0? Did I do the print wrong? That did feel weird, actually. No. Okay. I expected VA to have the value of 1000 hexadecimal, which is the virtual address of this program. It's 0. Why is it 0? Have you ever tried don't take it as an insult, but have you tried React? Yeah, I've tried React Native. Tried. I was forced to. It's incredibly bloated, inefficient, and horrible to work with. I don't understand how I became... Wait, so the minimum address is actually 0. That's weird. Where are you getting this minimum address? Seems like there's an entry here that has its virtual memory set to 0. And that's just kind of messing everything up. I mean, not really, because everything's working besides what I'm doing right now. Load to 0, 0 plus 0. At 10,000. What now? Now, trying to interpret this log, what it's supposed to mean, I have no idea, to be honest. But, yeah, this process, for whatever reason, sets its address to 0. Alright, well, if it works for you, it works for me. Alright, so address VA0 corresponds to code. So in reality, it sits at this address, ctx code. All right. So for each of the functions inside of here, I need to translate them as ctx exposed fs any I have to do it manually for all of them. I don't think there's a more efficient way of doing this right now. Open. Read. Write. Close. S. Read. I'm coding for like, I don't know, more than 10 years. Okay, so I have to manually translate all of these. Which you do by taking their addresses, subtracting the starting point, no, the VA point, which is 0 in this case, and then adding, wait, and then adding this address. Okay. Nope, apparently still no. So can you tell me where the process's like init function is? I did the login wrong. Let's go again. No, it's fully custom. Okay. 45 FC13D4. Hold up. Hold up. Four five FC crashed. Why is the heap located at 45 F7? How did that happen? Oh, it just reused an existing page. That's how it works. Okay, so I got the address for that wrong. But for example, I am doing some other translation of like the entry point to the function. No, I'm not. No, I'm not. Test is like here I'm doing all the mappings, and I'm mapping, for example, like the minimum address to dest plus the minimum address minus the minimum address, which is 0. So the minimum address maps to dest, which means that the minimum address gets assigned to this, and this gets assigned to this. You would expect the values to be correct. And yet they're not. Unless I did the math wrong. When this address is the baseline address, and this address is its equivalent baseline address, this is virtual, this is physical, then this address for the function translates to this minus this plus this. Right, because that's... This minus this gives me the offset that the function is relative to the beginning of the code. And then I take that offset and I put it here. So it's function minus virtual address plus code, which seems correct to me. Okay, I guess we'll figure this out after the ad break that's coming up on Twitch. So I'll be back in 3 minutes. Okay, we're back. Putting on headphones like there's anything to listen to. Except for the occasional text-to-speech, which is only available on Twitch, and right now most people are on YouTube, so... yeah, not really. Um... I'm a little surprised that this is not working. You know, the translation here is happening correctly. The function was 13D4. It's now F5 45F C13D4. So what exactly is causing this to happen? Wait. Probably just forgot a little step. Yeah, I forgot a little step. Just to translate all of these to kernel level. So that is fizz to vert. Wait. Fizz to vert. P. Okay, that works. It is on GitHub, yes. And I really thought that was gonna work. Why did I think that was gonna work? God damn it. I did put a function there, right? Yeah, here it is. Wait. Oh no. Unused variable? Your mom's unused. Come on, man. No, the address didn't change. Ooh. Okay. Hey, Penguin. I thought the print was causing issues because that itself calls a syscall internally. Luckily, that's not it. Though it might become an issue in the future. That's gonna be a fun one. Fuck. Well, I'm hoping not anyway. There should be no optimizations, but... yeah, it doesn't look like the instruction changed whatsoever. Also, the print wouldn't even be the first instruction of this function, so no, it's definitely not it. Hey, Kaiso. What is the problem? It's hard to tell what's going on, really. It has a value? Again, I'm double checking the math here, and it's perfectly fine. Okay. Code takes 12,000 from 0 to 12,000 and allocated space for process between F5C and FD. And then it just happens to put the stack FFE and this at F7. Which is before the process, essentially. The stack ended up there somehow because free in memory. But it does very much look like the process exists within this address. Uh, 45C 1324. It's very similar to this. Both of them are being mapped as executable. So confused. I mean, if I want to do the same math here, it's entry minus VA gives me an offset plus dest. That should give me the non-virtual address. Well, clearly not. One four four C was the entry point of that. 144C, yeah. This is so weird. But what should be something really dumb with the math? I mean, that's definitely what it is. No, it apparently cannot find the process if it's located at 45FC144C. But if it's at just 144C, then it works fine. Which makes no sense. Wait, L4 table missing. Ah, wait, hold on. I also need to map. Or, no, physical to virtual memory. Hey, hi, Steve. Okay. When I do it in the right place, it works. But then when I try to access it here, it doesn't. And I'm pretty sure this is, for whatever reason, only showing the 32-bit version of the address. Whereas I wanted to use the 64-bit version of it. Oh, it's using a string format. I didn't realize we were being fancy like that. It is trying to access the correct address. It just doesn't work. I think I'm doing the math right at this point. There is a function being called. I do wonder. Can I reference myself? It's an incompatible function type.
IOP text to speak is working today.
It is working, though the size is wrong, but we'll fix that real quick. Maybe without dragging everything with me. Let me try GDB real quick. Watch it be useless. It closed up. When I try to run GDB and my code on the same terminal, either QEMU or GDB does this really beautiful thing where if I press Control C, which is what GDB and their infinite fucking wisdom in that incredible program that it is, decided was going to be what you use to stop the execution of the program. QEMU quits their program entirely, because that's the key to quit the program. Except it isn't on QEMU, it's only in this case. But, God, what a poorly designed system. Both of them have done incredible... Well, where do I even test this? Alright, what's the address? This one, right? I forgot that even copying and pasting in a Linux terminal is complicated. No line number information, okay. Can you tell me what is at that address? Is there any instruction there, perhaps? Remote connection closed. God, using GDB just pisses me off. There's nothing good up. There's nothing good about it. Why did it just crash my system randomly? Alright. Is there an instruction at this address? There is a perfectly valid instruction at this address. So I did the math right. And let me guess, it's the same instruction as it is here. So I did the math right. So what the fuck is crashing? Permission fault level 3. It is marked as executable because I am literally executing. Unless... Wait. Can I print the address of a function? Like, can I hold the function as an argument here? Like this. Yes. And then... Wait. Alright. Don't want to use you ever again. Thank you. That is the exact address of the function. So maybe it was the address of the property that holds the function, but no, that is the address of the function. It is there. It is in memory. It is accessible. So what is the problem exactly? It does access the function. perfectly fine. But when I try to follow it from outside of here, I'm not allowed to. Alright, I think I know what it is, and it kind of makes this a little bit more difficult. It's not? Is this a joke? Okay. What I thought was happening is that there is a permission bit called the privileged execute never. First off, stupid name. But also, it means if this bit is set, the kernel cannot execute this code. Reasonable, right? Well, sure. Except I set it to 0, which means the kernel can execute this code. Why is it not working? Why is the kernel unable to access the function? If I set this to 0, the whole thing's set to 0 now. Nope. I am reloading, right? Yeah, make run. Boy, I have no clue what's going on. Okay, the issue with this is that it's a permission thing. Now, I don't know about userland processes having access to this thing. I'm okay with not having them do that. Just yet, anyway. Not giving them permission to have modules just yet. But allowing the kernel level processes to do it. Because that's where I want to use it. Then if a random application can just mount itself to the file system, that's maybe not the best thing just yet, so I'm okay with waiting for that. But it is weird that it doesn't work, even when I turn this off. Which again, turning this on off is a hack, and getting it to work properly is a thing that's kind of unnecessary right now. I have to think about the entirety of, security when it comes to userland processes before I think about this. So I don't necessarily want this to work right away, but I do want it to work, you know. Okay. So yeah, the userland part is going to have to wait. But I think I can continue developing this, testing it on a kernel level process, I guess. But one that actually quits, because when I tested it on one that doesn't quit, well, that doesn't really do a whole lot. So, the syscall code, this whole thing, this whole thing, I'm gonna call load process module, well, context first, module second. That returns a boolean, load process module, process pointer, module, system module pointer. Here should be fine. Returns a boolean, not a BPP. Now all these references to CTX. God damn, there's a lot of them. Holy. Alright, hold on. There should be a way to do this. Toggle search selection, CTX, search and replace with P. Okay, then select these, but I can do them manually. Yeah, for ARM it's SVC for 64-bit, but yes, it is like you're saying. The syscalls are literally just that one instruction, which is why I can modify their signature without having to modify the actual like function or anything like that. Okay. So what I will do is simply not have the syscalls available for it, just use this function instead. Right, so let's say that ping. Right, so the entire module that I just created is moving again. It is now moving to ping, because that's a kernel level process that's expected to quit. If I can find its entry point, here, I believe anyway. Okay, you wanna load the process module. Now you need a reference to the process. So just get current proc. Then the module is test mod. Okay. Yeah, the whole syscall is. I might keep just the implementation, but just disable the actual syscall. I don't know. How do we know that it worked? Well, we don't, apparently. That's the run process. Loaded module. All right, process exits, but it doesn't actually unload the module now, does it? Doesn't look like it did. I just skipped the part where I actually assign it. So, yeah, that's kind of a miss on my end. The terminal is a little bit buggy, to be honest, but it is working correctly. When I quit the process without having to explicitly unload the module, it initializes the module, says that it loaded the module, exits the process, unloads the module, calls the deinitializer, and then actually says that it unloaded it. So we're good. All right. I need this for kernel level processes. So what I'm gonna do is I'm just gonna disable the syscall because most likely the way that it will have to work in what is it called? I love how my camera changes colors when I move. The way that it will have to work in userland processes is they will have to have a dedicated section to code that can also be executed by the kernel, which is going to be this code. As well as probably eventually also like asynchronous code. Well, I don't know if any of that will be needed. Obviously, you can't have the actual like callbacks for asynchronous functions in the kernel. But if there's any code that needs to be executed in the kernel. Yeah, you know what? This whole thing seems like it requires a lot of thought. And yeah, I will have to think about process security. I kind of want them to have their own like sandboxed version of the file system. I don't want them to be able to access the file system, like the entire file system, which they currently can for convenience for me, but it shouldn't be that way. But I don't know how I want to do it. So I'll need to think about that, and I also need to think about like how to do modules um, properly. For the time being though, I am leaving the code. I'm just commenting it out because it doesn't do anything. Okay, and I'm not gonna lie, my headache is not necessarily getting better, so I might need to end the stream. I got what I needed, but not what I wanted, I guess. No, I got what I needed and what I wanted, just yeah, when it comes to user-learned processes, you have to be a little bit more careful when it comes to this type of stuff. Can't really just say, oh yeah, just let the kernel execute your code. That seems like a very easy way to get access to privileged code. To privileged code execution, I mean. So yeah, maybe we don't want that. Program from 2017, just like that, nothing. You're saying 2017 like we're talking like. I was gonna say 10 years ago. It was almost 10 years ago, but I mean you're talking 2017 like it was like the 80s. Well, yeah, backwards compatibility is nice. It's just not worth stopping the progress of technology. Like, you know, uh, Windows. But yeah, most likely I will end the stream, and there is a possibility. Wait. Oh God. Um, Technically, I didn't make any changes to the shared library, funnily enough. All I did was add some code that I then commented out. But working with Git submodules is such a pain in the ass. Okay, it figured it out. Oh, but I do have this, so yeah, no, I do need to. Um, yeah, disabled for security, not because of a crash. Although the crash is because of security. Essentially, if I want it to work, I have to figure out how to run that code from anywhere without letting the a random process have privileged code execution. Okay. All right. Could you not have included the file that I asked you to include in the commit? Was that too hard to do? Git pushed failed. Refusing to allow a personal access token to create or update workflow GitHub workflows build YAML. Excuse me? GitHub workflows? GitHub workflow. Oh, I did update it. I made it so that it doesn't rebuild the system with every change to the main branch. So now I have permission issues because GitHub is cute like that. GitHub. That's my own fault for using GitHub, I guess. God awful platform. Although this is for security too, it's just for the love of God. Alright, that's another thing that I want to do on stream. Alright, so like I said, started out with a headache today, not feeling amazing, don't feel like continuing. But backwards compatibility is kind of a pain in the ass because you make a bad decision in the 80s and you still have to deal with it in the 20s. Or somebody that either was someone made a decision before you were even born and you have to deal with the consequences of that in the 20s. It's dumb. Anyway, yes, I will be ending the stream even though it's been less than 2 hours. Today I was planning on doing two things. The first one was this that I just finished, and the second one was improving my compiler a little bit. So I was actually I have a little list since I did it. Yeah, we're planning on doing some compiler improvements. Maybe I'll have time for that tonight. If I feel better, it probably won't last that long. I'll feel better, but I guess stay tuned to Discord, but don't. Oh my God, what is wrong with my camera? That was yellow. It's yellow, pink, blue. It's just going through all the colors. Um, yeah, maybe tonight I'll work on the compiler a little bit. If not, I'm gonna work on it tomorrow. Again, stay tuned to my Discord if you're interested. And yeah, to be fair, I barely showed the OS, so might as well. Alright, stay tuned to the Discord. I will announce it there if I happen to do another stream today. If not, tomorrow's stream will probably be fine by then. So we'll be at 3, pretty much the same time as today. So an hour and a half ago. This is what it looks like right now, but that's kind of a... Oh my god. It's not Linux, it's a custom kernel. This is the window manager, right? It opens this window in near full screen. And then I made it so that you press Command arrow, and that moves you to the next screen over. And when I'm inside of QEMU, I expect all the keystrokes to stay within QEMU, but they don't. Okay, now it works. So I just wasn't focused. Alright, never mind. Rant over. False alarm. Yeah, that's what it looks like, but yeah, the Windows system is... I honestly haven't needed to make my windows anything more than just full screen like that. That works really well for me, but you can also draw them, which is the main way that I do windows. Okay, maybe you don't draw them that small. I don't know what's happening with my mouse. You're kind of not supposed to zoom, so... Not on this GPU anyway. It looks a little bit weird, but normally the way that it works is you can draw windows and then you can move around. And you can also create windows, but the window manager doesn't work really well with the drawn windows. Again, I'll improve it when I need it. Okay. Yeah, everything that I did with the file system. For kernel level processes, we're there, we got it, the code is there. For other processes, no. And I have to, there's a lot of considerations that I have to do before I even consider fixing the bug that I found. So it's easier to just disable that functionality for user-land processes. Okay. Either tonight or tomorrow, what I'm gonna do with the compiler is a little bit better type checking. I needed to understand the difference between when something is a pointer and when something isn't a pointer, so that when it translates the code to C, it actually makes sense. And maybe even be able to detect some symbols, because the library that I mostly rely on for the code is in C, and the parser compiler doesn't compile C, so it kind of cannot see those symbols. So maybe I have to create a way of giving it those symbols without having to compile them. I don't know. I guess we'll see that either tonight. Again, stay tuned for Discord, to Discord if you're interested in joining, or to, notifications on here. And if not, tomorrow I'm gonna work on the compiler. Alright, thank you so much everybody for joining. I'll see you next time.